Have you ever wondered, deep beneath the ocean's surface, how many creatures are silently sustaining all of humankind? Through tempests and blizzards, humans continue to venture out to sea, defying nature to bring back over 180 million tons of seafood every year, the result of courage and an unyielding will to conquer. Behind that staggering number lies a new era of the seafood industry, where human intelligence and mechanical power unite, transforming fishing from a struggle for survival into a global enterprise. Don't take your eyes off this video, because up next are the most breathtaking scenes of the modern ocean, where science, technology, and human bravery converge in the quest to conquer the hidden treasures of the deep. Now, let's begin with the fiercest hunt in the ocean, where humans face off against the planet's most notorious predator, the shark. The first step may seem simple, but determines success or failure: choosing the fishing ground, coral reefs, nutrient-rich ocean currents, or areas where bait fish gather. Once the location is set, massive walls of net stretching for kilometers are cast into the sea, and when a shark swims by, its fins and steel jaws, symbols of its power, become the very chains that trap it. However, this method often harms non-target species, so many countries have tightened regulations, limiting soak time, mesh size, and requiring bycatch release devices to protect marine ecosystems. That's why modern fishermen are turning to longline fishing, a method that demands strength, skill, and determination. When a shark takes the bait, the deck instantly becomes a battlefield, where humans and apex predators struggle for dominance. The key to success lies in fresh bait and low-frequency sound devices that mimic bait fish movements to lure sharks in. On industrial vessels, sharks are processed right on deck, stunned, then injected with cold seawater or ice into their gills and body cavity to preserve peak freshness until the ship returns to port. The grouper? A sea giant with a blunt snout, a powerful body, and a cold, steel-like gaze, is now harvested mainly from large-scale offshore cage farms along the coasts of Southeast Asia. When the harvest season begins, massive sea cages are gradually narrowed, driving the groupers toward the center. From the deep water, 20 to 30 kg giants slowly emerge, their firm bodies and shimmering golden-silver scales glinting under the sunlight, showing they've reached peak physical condition. Fishermen work with swift yet precise movements, using soft, specialized nets to lift each fish gently out of the water. Every motion matters. Even a small scratch can reduce its market value. The freshly caught groupers are immediately placed into oxygenated seawater tanks, helping them stay healthy and calm before reaching the shore. On deck, the harvesting crew follows a strict protocol, checking the water's temperature and salinity, monitoring each fish's condition, and ensuring that every specimen meets quality standards. This marks the culmination of over 2 years of continuous rearing, monitoring, and care powered by modern aquaculture technology. Each harvest not only holds significant economic value, worth tens of thousands of dollars, but also reflects the seamless coordination between advanced farming techniques and the fisherman's expertise. These prized trophies are swiftly transported to processing facilities, ensuring they retain the same freshness as when they were still beneath the sea. In the cold northern waters of Japan and South Korea, when sea temperatures stabilize around April to May, sea pineapple, Halosynthia raretsai, farms enter their peak harvest season, the moment that marks the culmination of an entire year of cultivation. In highly mechanized farms, the harvest operates like a finely tuned assembly line. Long ropes densely covered with sea pineapples are hoisted out of the water using hydraulic cranes or pulley systems attached to specialized harvesting vessels. As each rope passes through the stripping chamber, Hundreds of sea pineapples are automatically removed by a rotating drum system that combines twisting force and water pressure. The process takes only seconds but demands absolute precision to avoid damaging the spiny outer shell or the delicate inner tissue. Once detached, the sea pineapples are collected into large plastic containers or mesh bags, then lifted by hydraulic cranes and transported immediately to shore or to floating pre-processing stations near the farms. This minimizes transport time, prevents temperature-related spoilage, and preserves the natural freshness of these deep-water creatures. In smaller or traditional farms, however, semi-manual methods are still used. Each hanging rope may carry 100 to 150 mature sea pineapples, weighing up to 45 kilograms per line. During harvest, farmers use winches or manual pulleys to lift the ropes, securing them to the boat's sides or to large floating buoys to reduce impact. Dozens of lines are pulled up one after another, then slowly brought to shore, where coastal processing stations await. Though more labor-intensive, this traditional approach keeps the sea pineapples in their natural seawater environment until the final moment, preserving their fresh flavor and reducing biological stress before processing. Across tropical Asia, freshwater shrimp farms enter harvest season right after the rains, when pond water is lowered, ready for large-scale collection. It's the final stage of months of care, where skill, speed, and precision reach their peak. Farmers cast wide nets, working in rhythm. One group holds steady, while the other tightens the circle, driving thousands of shrimp toward the center. Beneath the surface, their firm, flicking bodies signal a perfect crop. Once enclosed, shrimp are quickly scooped up and transferred into oxygenated or chilled tanks to preserve freshness and vitality. Every step is closely supervised, from timing to post-harvest handling. For farmers, this is more than work. It's the culmination of a year's dedication, where each catch reflects their skill and pride. Off the coast of the North Atlantic, another hunt begins. The pursuit of the northern red shrimp, a rare species dwelling in some of the coldest and deepest waters on Earth. Out in the vast ocean, fishermen follow natural signs, seabirds circling above or sonar signals indicating shrimp layers at depths of 150 to 400 meters. Once the location is confirmed, the order to deploy the nets is given. Giant winches and pulley systems lower funnel-shaped trawl nets to the seabed. Two large otter boards keep the mouth open as it sweeps across soft sediment where red shrimp hide. Inside, biological sorting devices automatically release turtles and other bycatch, ensuring a sustainable and responsible harvest. After 3 to 6 hours, the nets are hauled back up, bulging and heavy, a sure sign of a successful catch. The red-pink shrimp spill into the loading hopper on deck, where the automated processing system immediately takes over. Washing, grading, and flash freezing at -40 degrees Celsius to preserve their natural color and firm texture. From the moment they leave the deep sea to the time they are stored in onboard cold rooms, the entire process takes just a few minutes, a testament to the precision, speed, and technological power of modern Northern European fisheries. Continuing our journey, let's head out to the vast Atlantic Ocean, where specialized fishing vessels surge through the waves, launching a spectacular pursuit known as the mackerel hunt. In this modern chase, no method proves more effective or breathtaking than the purse seine. A massive net stretching hundreds of meters, released into the sea to form a tightening circle, like an invisible trap beneath the waves. Speed is the key to success. The faster the net closes, the slimmer the fish's chance of escape. As the final line pulls taut like a steel noose, tens of tons of shimmering mackerel are enclosed within a swirling silver mass, churning violently beneath the foaming water. Powerful hydraulic cranes roar to life, rhythmically hoisting each heavy catch and pouring it straight into deep freezing holds kept at 22 degrees Celsius, preserving their pristine freshness. In less than 30 minutes, a single haul can yield over 200 tons of fish, a bounty that once took an entire fishing village weeks to gather. It is not merely the triumph of technology, but a relentless duel between humankind and the sea. Among hundreds of fish species in the ocean, only the pufferfish can make fishermen both crave and fear it. Catching tuna demands speed, mackerel requires nets, but catching pufferfish? That's like playing with knives on a stormy deck, where every move flirts with danger amid freezing winds and crashing waves. The hunt begins with the most crucial element, bait. But not just any bait will do. Pufferfish are notoriously picky. Fishermen must use freshly caught mackerel, carefully cleaned, trimmed into perfect cubes, and salted to preserve freshness. If the mackerel oil turns rancid, the pufferfish won't even come close. Each day, up to 20,000 bait cubes are prepared and packed into 250 ice boxes, all for a single 48-kilometer-long line, strung with over 20,000 razor-sharp steel hooks. Once the bait is ready, the massive line sinks slowly into the sea, its thousands of hooks forming an invisible web beneath the surface. But that's when the real risk begins. A sudden gust of wind, a lost buoy, and hundreds of hooks, worth thousands of dollars, vanish into the abyss. Many fishermen have gone bankrupt after a single unexpected storm. Catching pufferfish isn't just a trade, it's a high-stakes gamble with the ocean, where the line between ruin and fortune is drawn by just one pull of the hook. Tilapia, the most widely farmed white fish on the planet, with an annual yield exceeding 6 million tons, is often called the chicken of aquaculture. It's primarily harvested in the warm waters of Asia, Africa, and Latin America, where stable climates and abundant fresh water create ideal growing conditions. Harvesting is carried out using large seine nets or specialized fish pumps. As tens of thousands of fish are drawn together, the surface comes alive with movement. The harvest crew works in perfect sync, closing the net gradually, herding the fish into a central area. Every motion must be precise, fast enough to prevent escape, yet gentle enough to avoid bruising scales or breaking fins. Once gathered, the fish are transferred directly into aerated tanker trucks, the first-class cabins of aquaculture transport. Inside, water temperature and oxygen levels are carefully regulated, keeping the fish healthy and alive all the way to the processing plant. From netting to transport and handling, every step is timed to perfection, because just a few minutes' delay can affect meat quality due to biological stress. For fish farmers, this isn't merely a technical process, but a code of respect for the creatures they raise and for the hard work that sustains their livelihood. Unlike white clams or scallops, which are often harvested on an industrial scale using sand suction dredgers or powerful trawl boats, blood cockles remain largely tied to traditional manual harvesting methods, a rhythm deeply woven into coastal life. When the tide recedes to its lowest point, a narrow 2-3 hour window each day, hundreds of workers spread across the mudflats, bent low, hands digging and raking. Some use 10 to 12-tooth steel hooks attached to long handles, gently scraping the soft mud to uncover shells buried 5 to 10 centimeters deep. Every movement requires precision and sensitivity. Too much force, and the shell breaks. Too little, and it slips deeper into the mud, losing its market value. Yet, to meet the rising global demand, many coastal farms have begun adopting controlled mechanization, integrating modern dragnet systems. Heavy nets are lowered into the muddy seabed, plowing long strips and gathering clusters of cockles, which are hoisted up by hydraulic cranes. Within minutes, hundreds of kilograms of shellfish are dumped into onboard bins, then immediately washed, sorted, and packed on the vessel itself. Compared to the traditional sun-drenched hand-picking on muddy shores, this new method is 5 to 10 times more efficient, yielding 5 to 8 tons per day. But that speed comes at a price. High investment costs and the risk of disturbing the seabed ecosystem, threatening plankton populations and natural broodstocks that sustain future harvests. Every November, the North Atlantic turns into a battlefield of scale. Massive shoals of sardines, weighing millions of tons, light up sonar screens like blazing red storms beneath the waves. The moment a signal pings back, crews lock on target, unleashing purse seines over a kilometer long. Hydraulic winches tighten, thousands of buoys rise, and suddenly the open ocean folds into a colossal steel trap. In one haul, tens of thousands of tons of shimmering silver fish are captured, a sight that once demanded an entire fleet. Giant vacuum pumps roar to life, sucking streams of fish on board while keeping every shimmering scale intact. Their power can swallow hundreds of tons in just minutes, dozens of times faster than human hands ever could. With this technology, the ocean feels as if it's being drained through a colossal straw, both brutal and breathtaking. In moments, sardines are sealed in icy holds, preserving the flavor of the ocean and ready to serve millions of meals around the world. The journey of sardines doesn't end at our dining table. Out in the vast ocean, they serve another purpose, becoming the lifeblood that fuels the giants of the sea, tuna. And to satisfy the hunger of these ocean warriors, technology once again steps in. Automatic feeding machines act as silent chefs. Fishermen simply load the boat with fresh sardines or nutrient-rich pellets, and the system takes care of the rest, grinding, pumping, and evenly scattering feed across the pens, creating mesmerizing rainfalls of food on the water's surface. The tuna surge upward in unison, devouring the feast, growing bigger and stronger. Thanks to this method, feeding becomes more uniform, costs are reduced, and waste is minimized, transforming offshore farms into sustainable meat factories of the sea, securing a stable supply for the global market. The purse seine method, using nets up to 2 kilometers long and nearly 200 meters deep, is considered the ultimate weapon in tuna fishing across Spain and Mexico. With this technique, entire migrating schools of thousands of tuna can be encircled, contributing to more than 7 million tons of catch each year. When sonar signals the presence of a school, the crew springs into action. A small boat pulls the leading edge of the net in a wide circle, while the mothership steadily releases the massive mesh, closing the trap. Floats keep the mouth of the net at the surface, while heavy weights drag the bottom deep down, transforming it into a colossal moving wall that seals off the churning ocean. After hours of tightening, the tuna are corralled together, thrashing furiously in the shimmering water. At this point, fishermen deploy giant braille nets, scoop-like nets the size of swimming pools, to hoist clusters of fish aboard. The entire operation is powered by heavy-duty hydraulic winches and cranes, capable of lifting tons of tuna in a single sweep. This not only spares the crew from back-breaking labor, but also drastically cuts down harvest time. In October, the Bering Sea turns furious, where fishermen plunge into a deadly race to seize a fiery treasure, the king crab, one of the most dangerous trades on Earth. Giant crab pots, steel frames weighing over 300 kilograms, wrapped in tough mesh and packed with herring bait, are hurled into the depths, 200 to 400 meters below. Each trap, marked with a GPS buoy, sinks into the freezing darkness where the giants of the deep lie in wait. After 24 to 48 hours, the golden moment arrives. The massive cages, heavy with their catch, are hauled back by hydraulic cranes, powerful enough to lift tons in seconds. Replacing the back-breaking labor of dozens of deckhands, this machinery shortens the harvest and slashes risk in the raging seas while multiplying efficiency. When the traps crack open, dozens of scarlet king crabs tumble onto the deck, and sorting begins immediately. Only mature males, with shells wider than 16.5 centimeters and weighing at least 1.2 kilograms, are kept. Females and undersized crabs are returned to the sea to preserve the population. The prized survivors are placed into chilled seawater tanks, kept alive until the boat reaches port, sealing another triumphant season on the perilous Bering waters. Farewell to the wild ocean. Today, over 80% of the world's salmon comes from massive offshore farms in Norway and Chile, where aquaculture techniques have reshaped the entire seafood industry. The journey of salmon begins in the hatchery, where eggs and milk are fertilized under strict conditions. Just a few weeks later, the eggs hatch into fry, raised in freshwater tanks with carefully controlled temperature and oxygen. Once they reach 10 to 15 centimeters, they undergo smoltification, a remarkable transformation that allows them to adapt to seawater. At this stage, the young fish must be transferred to massive offshore HDPE cages, where cold, oxygen-rich currents help them grow rapidly. And it's precisely in this critical moving day that an ingenious technology comes into play. Can you believe fish can actually take an elevator? On modern farms, moving tons of live fish is now done with a machine called the fish transfer pump. Instead of blades that could injure them, the pump generates a gentle, low-pressure water flow that sweeps the salmon smoothly through pipes like a water slide, before shooting them directly into transport tanks or holding pens. The result, a safe, fast, and almost stress-free journey for the fish. Born in Japan in the 1970s, the automated squid jigging method with slide troughs quickly became Asia's most effective squid harvesting machine. Modern vessels are equipped with massive dual-side rigs and hundreds of glowing artificial lures, turning the night sea into a floating city that draws dense schools of squid. Artificial light doesn't just attract squid, it concentrates them at optimal depths to avoid predators, boosting catch efficiency several times over. The automatic line system springs to life. Motors make the lines twitch like live prey, luring squid that are then guided along the troughs into containers, keeping their shape and freshness intact. While a typical squid only lives a few years, this technology allows millions of tons to be harvested annually without disrupting the ecosystem. One by one, fresh squid are collected, turning each voyage into a feat of human ingenuity, where technology and nature combine to create a breathtaking performance on the night sea. On the muddy tidal flats of North America, high-pressure water pumps have become the most advanced tool for harvesting a rare treasure, the geoduck clam. Workers balance precariously on the soft mud, inserting the tube precisely where the clam buries itself, a meter deep beneath the sand. The powerful jet loosens the ground, turning the compact sand into a liquid stream around the clam. Once the sand softens, they carefully dig layer by layer with their hands or a small shovel, gradually lifting the massive clam intact its long body stretching like a human arm. The biggest advantage of this method is saving effort and drastically reducing harvesting time. Yet it comes with harsh challenges. The tides. A sudden rise can submerge the exposed flats in an instant, sweeping away tools and hard-earned clams in the blink of an eye. It's a heart-pounding race between humans and the sea, where only the swiftest and bravest can claim the prize. Abalone, the luxury seafood often called the diamond of the sea, is now in full harvest season across many Asian waters. The process begins by hoisting heavy cultivation trays, each holding 200 to 300 clinging abalones, onto the boat using cranes or automatic winches. Workers then carefully detach each abalone with specialized tools, ensuring the foot, the most valuable part, remains intact. Next, the abalones are rinsed clean of seaweed and sand, then fed onto an automated conveyor for sorting. Each individual is graded by size and weight to meet strict standards. Japan demands absolute uniformity, while China seeks giant specimens for high-end restaurants. Finally, the abalones are packed in oxygenated foam boxes or chilled, ready to be shipped worldwide, where they grace luxury dining tables at staggering prices. Scallops, the pearls of the ocean, aren't lured like sardines by light, nor tricked like squid by fake bait. Harvesting them requires precision and the skilled hands of experienced fishers. Techniques include longline pulling or bottom trawling, where expertise makes all the difference. As hydraulic cranes lift dozens of meters-long lines, thousands of scallops cling tightly, revealing themselves like massive strings of raw pearls, their shells sparkling in the light. Each heavy line represents nearly a year of enduring waves and cold currents. And did you know? A scallop can live over 20 years, accumulating exceptional flavor and nutrients throughout its life. With bottom seeding methods, harvesting is even harsher. Nets scrape the seabed to gather scallops, yielding large quantities but disturbing the marine environment. Today, suspended line farming is on the rise. Sustainable, preserving the quality of each scallop, allowing fishers to harvest safely, and turning every trip to sea into a breathtaking display of nature and technology. In modern factories, the scallop shelling process is now fully automated, easing the workload for workers while maintaining speed and precision. Workers only need to place the scallops on the conveyor belt, and the rest is handled almost entirely by mechanical arms. A thin blade glides along the shell, splitting it open in an instant, extracting the pristine white adductor muscle, while the shells and innards are swept aside. A single production line can process 8,000 to 10,000 scallops per hour, cleanly, quickly, and accurately, perfectly suited for export orders. What makes coastal mussel farming so unique and highly productive is the fleet of specialized boats equipped with hydraulic cranes and massive mussel harvesting buckets. When approaching the posts, the bucket is lowered close to the surface and works like an automatic scrubber. It dislodges the mussels while washing away mud and debris using high-pressure water jets. The mussels that fall are sucked into a collection chamber and transferred directly to the ship's hold, speeding up harvesting, reducing labor, and minimizing damage to both the posts and the mussels, compared to manual methods. At offshore rope mussel farms, harvesting has been mechanized with an automated mussel sorting machine on the deck. When the long ropes, tens of meters in length, are lifted, they are fed into the system. Rotating spines combined with stiff brushes and high-pressure water jets scrub the surface, dislodging the mussels, lightly sorting them, and collecting them directly into storage bins. In just a few minutes, thousands of mussels, weighing hundreds of kilograms per rope, are processed neatly, much faster than by hand. If China is known as the catfish processing capital of the world, holding up to 60% of global output with its dense network of ponds and factories across the southern provinces, then the United States is the ultimate battleground outside Asia, one of the most demanding markets, where every single cut of fish must pass a gauntlet of strict standards for hygiene, texture, and food safety before earning a place on the dining table. For decades, catfish has been hailed as the king of affordable seafood, prized for its rich sweetness and exceptionally reasonable price. While 200 kilograms of catfish may only fetch the price of 1 kilogram of bluefin tuna, nutritionally, it stands tall, with high protein and low fat, proudly sharing the stage with some of the world's most prized seafood delicacies. Catfish is instantly recognizable by its long, whisker-like barbels, ultra-sensitive feelers that help it locate food and navigate through murky, dark waters. These living sensors allow catfish to detect prey and read their surroundings with precision, making them cunning and agile hunters beneath the surface. To maintain and improve the quality of catfish breeds, the fertilization process is carried out methodically and strictly, starting with the careful selection of elite broodstock. Once meticulously chosen, these superior broodstock enter a closed and highly controlled breeding cycle. The female catfish are injected with ovulation-inducing hormones, commonly HCG or a dalmatilium mixture, then left for 6 to 12 hours until the eggs reach peak maturity. At the right moment, the eggs are gently collected into clean trays, while milt from the males is obtained either by abdominal stripping or directly from the testes. Every step at this stage must be performed with absolute precision, speed, and sterility, as even a minor mistake could jeopardize the entire batch of fry. Unlike salmon or sturgeon, famed for their prized roe, catfish eggs have a rich, fatty taste and a pronounced fishy aroma. And if the mother fish lives in polluted waters or is diseased, the eggs may contain pathogens or heavy metals, making them unsafe to eat when their origin is unknown. The eggs and milt are then gently mixed in an activating solution and evenly divided into specialized trays placed in a strictly monitored environment for temperature, humidity, and hygiene. Immediately after fertilization, the eggs are not incubated right away. Instead, they are kept in large trays to stabilize. Initially, the eggs appear pale yellow and slightly translucent, indicating that the embryos have just begun forming. Next comes the cold preservation phase, where the water temperature is kept consistently cool to prevent thermal shock and fungal growth. During this period, the eggs gradually turn a light pink, a sign of healthy embryonic development. When the eggs reach optimal biological maturity, technicians carefully remove, rinse, and transfer them to specialized incubation systems. Each batch of eggs is the result of a process controlled down to the exact degree Celsius and every drop of water, ensuring a solid foundation for the success of the future catfish generation. In just 24 to 36 hours of incubation, catfish eggs begin to hatch, revealing tiny, translucent beings drifting like dewdrops in the water, the larvae gently swimming through the clear depths. Catfish hatch much faster than many other fish, thanks to their thin eggshells and rapid embryo development, adapted to the warm waters of tropical environments. This stage is extremely fragile. The larvae have no mouths and rely entirely on their yolk sacs for survival. They are kept in clean, aerated tanks with a stable temperature of 28 to 30 degrees Celsius and minimal water flow to protect the delicate young from injury. Each tank functions like a giant biological incubator, nurturing thousands of tiny lives growing by the minute, beginning their journey toward becoming healthy, valuable catfish. As the yolk sac is depleted, the fry begin feeding on soft, easily digestible foods such as Artemia larvae or finely mashed boiled egg yolk. After a few days, high-protein powdered feed is introduced, evenly sprinkled over the water in precise amounts. Feeding at the right time and in the right way not only promotes rapid, even growth, but also minimizes losses during these challenging early days of life. When the fish are strong enough, farmers take a crucial step, moving the young catfish into a larger grow-out environment. Tubs holding thousands of fry are gently poured into a transfer trough, where continuously flowing water helps them gradually adapt to the new conditions. From here, the fish are guided directly into expansive grow-out ponds. Not just a change of space, but a milestone in their development, where growth rate and survival will determine the success of the entire crop. A grow-out pond is not simply a container of water, but a carefully designed ecosystem optimized for the growth of catfish. With ample surface area, the right depth, and a continuous water exchange system, these ponds closely mimic natural habitats, allowing the fish to swim freely, digest efficiently, and achieve exceptional growth. Moving the fish into these ponds not only frees up space, but also marks the shift from intensive care to growth-focused rearing, the stage where the fish begin their rapid weight gain toward market size, readying for a successful harvest day. Under human care, catfish, once associated with the wild and muddy waters, are now raised methodically like true industrial candidates. About 5 to 6 months after the fry stage, they enter maturity. At this point, each fish weighs between 0.8 and 1.2 kilograms with a firm body, thick dark skin, and a healthy sheen, all signs that they have reached market standard. With an impressive growth rate, averaging 1.5% of body weight per day under proper farming techniques, catfish are considered among the most efficient freshwater fish in feed conversion, requiring only about 1.2 to 1.5 kilograms of feed to produce 1 kilogram of meat. But to achieve rapid growth, farmers must understand a key instinct. Catfish are voracious feeders. The moment they detect the sound of food hitting the water, the entire school rushes to the surface in a silent yet intense feeding frenzy. This is why modern farms no longer feed by hand. Instead, they use automated feed distribution systems mounted on specialized vehicles that run along the pond banks, saving labor while ensuring even and precise feed delivery for each growth stage. Each feeding session is like a military drill, carried out swiftly and with minute precision. As a result, the fish not only grow quickly and uniformly, but also experience less competition and injury, a crucial factor in maintaining high market value before the harvest stage. After about 5 to 6 months of farming, when the catfish reach an average weight of 1 to 1.2 kilograms, farmers begin the harvest, a stage that requires both strength and precision to ensure meat quality and minimize losses. The process starts by deploying a durable nylon seine net with a mesh size of 3 to 4 centimeters, gradually tightening it into a smaller circle to gather the fish into a holding area. On the surface, motorboats and divers work in sync, creating gentle water currents that guide the school into the net pocket, the final concentration point. Water churns and foams as tons of catfish thrash powerfully, creating a scene that is both noisy and urgent. Once the fish are concentrated, an industrial crane lowers a massive net basket, scooping up each heavy load of several hundred kilograms. Water drains quickly through the mesh to reduce lifting weight and prevent suffocation. The catfish at this stage are firm-bodied, with thick silver-gray skin and white bellies, clear indicators of premium-grade fish ready for sale to processing plants. Immediately, the fish are transferred into specialized tank trucks equipped with aeration and water circulation systems, maintaining a density of 150 to 200 kilograms per meter cubed. This is crucial as catfish are highly sensitive to environmental changes. Lack of oxygen or sudden temperature spikes can cause stress, lowering meat quality. At HACCP-certified farms, the entire operation, from setting the net to the tank truck leaving the pond, is completed within just 1 to 2 hours. The goal is to minimize the time the fish are crowded, preserving firm flesh texture and high market value before they move on to processing. As soon as the catfish arrive at the processing plant, they are immediately transferred into chilled saltwater tanks, a dual-purpose treatment that maximizes freshness while removing the characteristic slime from their skin. Next, the fish are passed through a high-pressure washing system where strong jets of cold water from multiple angles thoroughly clean them before they reach the sorting table. Only fish that meet quality standards are selected to continue along the processing line, while substandard fish are separated and handled through a dedicated procedure. In the pre-processing area, quality-approved catfish are handled without delay. First, workers remove the heads and internal organs either manually or with semi-automated equipment. Next, the fish are fed into a modern filleting machine, where razor-sharp blades neatly separate each slice of pale pink flesh, uniform and clean. Every step of the process is optimized to ensure speed, hygiene, and consistent quality, preparing the fish for the next stages of production. Although catfish do not have many fine bones, processing plants still carry out meticulous deboning after filleting to ensure absolute quality. In many traditional facilities, this step is done manually under bright lighting. Each fillet is placed on a cold stainless steel table, and workers use specialized steel tweezers to pluck out even the tiniest pin bones. Just one missed bone could lead to an entire batch being rejected in highly demanding markets such as Europe or Japan. Not every catfish is selected for premium filleting. Those that do not meet appearance standards are handled separately by being salted with refined salt and then quickly frozen to optimally preserve freshness and meat quality. The fish are then stored in strictly controlled cold storage, ensuring that their nutritional value and flavor remain intact before being processed or distributed, making full use of every part of the product in an efficient production process. For fillets that meet quality standards, the next step is entering the automated packaging line. Here, workers perform a final inspection before placing them into pre-formed trays. Each portion is precisely adjusted to the standard weight, ensuring uniformity and visual appeal. Finally, the products are labeled, printed with traceability codes, and neatly packed into chilled boxes, ready for shipment to supermarkets and demanding export markets. Each fillet, though simple in appearance, represents the result of an entire chain of sophisticated technology behind the scenes. Behind the chilled packaging lies the key ingredient for a classic dish deeply rooted in American cuisine: crispy fried catfish. The famous southern fried catfish is celebrated for its golden cornmeal-crusted exterior that shatters with each bite, paired with its signature mild spiciness, creating an unforgettable culinary experience. More than just a dish, it is an icon of soul food culture, where food nourishes both the body and soul of African Americans, evoking memories of family and community bonds. Compared to seafood like oysters, scallops, or green mussels, which can be harvested in just a few months, abalone requires at least 18 months to 3 years from its larval stage. Only when they reach a length of 6 to 12 centimeters, with a uniformly hardened shell, thick flesh, and stable weight, are they considered ready for harvest, marking the culmination of a long and meticulous farming journey. A harvesting process begins by lifting individual abalone trays from the sea, using cranes or automatic winches. Each tray usually holds around 200 to 300 abalones clinging tightly, weighing several dozen kilograms, so mechanical support is required to ensure safety and to prevent the abalones from falling off. Immediately after, workers carefully detach the abalones from the trays or rearing racks using specialized tools, taking care not to damage the foot, the most valuable part of the meat. Due to their extremely strong grip, many must be pried off with thin, specialized blades, and workers must handle them with precision to avoid tearing the flesh, which would reduce their market value. Next, the abalones undergo preliminary cleaning of their outer shells to remove algae, silt, and small parasites attached to the surface. They are usually rinsed with clean seawater or a mild disinfectant solution to minimize bacteria and help preserve freshness before the sorting stage. Here, the abalones are placed onto automated conveyor systems where each individual is separated according to size and weight. This meticulous grading not only accommodates diverse packaging needs, but also meets the strict standards of different markets. For example, Japan favors perfectly uniform abalones, while China prefers larger sizes to serve in high-end restaurants. Finally, after sorting, the abalones are packed into foam boxes with oxygen supply, or kept chilled, then transported to processing plants or distribution centers, ready for the next stage of their journey to dining tables around the world, particularly to high-end restaurants where absolute freshness is required. As soon as they arrive at the processing plant, the crates of live abalones are moved by forklifts directly into large cold water tanks, equipped with continuous aeration systems to maintain dissolved oxygen levels and reduce stress. This stage allows the abalones to recover after long transport and ensures the meat retains optimal freshness before processing. After this recovery soak, the crates are transferred to the processing line, where workers use specialized tools to carefully detach each abalone from the plastic trays or rearing racks. The next step is cleaning, a highly critical stage. Abalones are first scrubbed manually with soft brushes to remove algae, sand, and debris from the shell surface. They are then placed into rotary drum washing machines equipped with high-pressure water jets for a final thorough rinse. This process not only ensures food safety and hygiene, but also enhances the appearance of the abalones before further processing. Once the abalones are thoroughly cleaned, workers proceed to separate the meat from the shell using specialized knives. At the same time, they remove the viscera, digestive glands, and the dark-colored gut, parts that are not edible. This step requires great skill and experience to avoid tearing the flesh or damaging the soft fringe around the body, which is rich in nutrients. After being separated, the abalone meat is neatly arranged into stainless steel trays and placed into blast freezers at temperatures ranging from -40 degrees Celsius to -60 degrees Celsius. This rapid freezing method preserves the natural texture of the meat and prevents microbial growth. It is the most common preservation technique, extending storage life without the need for chemical additives. After freezing, abalones can be packaged either whole or sliced, depending on market demand. The packaging used is typically vacuum-sealed bags or molded plastic trays, ensuring that flavor, moisture, and food safety are preserved throughout transportation and distribution. For premium canned abalone products, the pristine white meat, after thorough cleaning, is carefully inspected by hand and eye to ensure it is free from defects. Each piece is then weighed with precision down to the gram to guarantee uniformity across every can, a crucial requirement in high-end markets such as Japan, the United States, and Singapore. Finally, the finished cans are labeled with detailed information on origin, production date, and expiration date before being boxed and shipped worldwide.